So far, we have learned how to create object, and object have methods. Now, when object interact with method, there are more tricky issues. The first one is to pass object as a method argument. When you pass an object as an argument, the thing that is passed into the parameter variable is the object's memory address. As a result, parameter variable references the object, and the receiving method has access to the object. Let's draw the memory stack again. So this is the memory stack. And let's say this is the caller. And this is the called method. So we have a caller. So we have caller, and we have called. When you create an object inside the caller, you are actually creating a variable which has the address, and this address points to the object that you created, right? Let me move this up a little bit. And let's say this object have a field. X initialized to 0. When you call this called method, the first thing is, let's say you are calling using one object and one int. The parameter of the called method has also two parameters. One is the object, which is also the address, and also have an int. However, as you can see here, this address is pointing to here, right? Because you are passing the address, so this called method also have access to the same object that is created in the caller method, whereas the int is just a copy of this int. Actually, let me do this instead. So I'm going to delete this and type in int, just to show that this is something that you created before. And here, this int, I'm going to handwrite to show this is just a copy. Right? This is just a copy of the original int. Whatever you change will not affect the integer inside the caller. But here, if in the caller you are changing the address.fx equals to 100, then this value here, it will be changed to 100. It will becomes 100. Later on in caller, you can call called. After called, if you print x, you will see that x becomes 100. So the value, not x, address.x. So the value of address x got changed during this call. So this is the first thing, that objects are passed by reference, right? Whatever change inside called method will impact the caller. Whatever object changed inside the called method will impact the caller. This is true for all objects. And there is one thing to note. If the object is immutable, that you cannot change, for example, a string, then that you don't need to worry about this part, that change inside called method. If it's string, that's why when you pass a string to a method, we never say you need to worry about the string being changed, because the string will not be changed. It's immutable. You cannot change that unless you want to have the string changed somehow. For example, a to uppercase. But in that case, you are not changing the string inside the method. Instead, you are returning a new object. So this is one, object are passed by reference, and two, if the object is immutable, no worries. But if you do want to change the immutable object, the method, the called method, must return a new object with the change you want. Okay, so hope this is clear enough. Let's reiterate using a PowerPoint slide. Objects are passed as argument, and the arguments are passed by value. So when the object is passed as an argument, the value of the reference value variable is passed, which is an address of the reference to the object in memory. A copy is not passed as a copy of the object. Instead, it's passed as the object itself. When the method receives the reference variable, it's possible for the method to modify the contents of the object referenced by the variable. So this is an example. When the caller calls display rectangles, it uses new to create a rectangle object called box, and the address is passed to this parameter rectangle R. When you type in, when you do get length, Java directly go to the object to get the length, and directly go to the object to get the width. And if you change the length here, then the caller later on, when they reference the rectangle object, it will get the new rectangle length. You can also return objects from methods. Methods are not limited to return the primitive data types. Instead, it will return a reference to the object. That's just what we talked just now, right? If you want to change the immutable object, the called method, oh, there's a typo, sorry about that, must return a new object. How do you return a new object? You will use a new keyword to create a new object. And by doing this, you are allocating a memory and put a new object's instance information there. And this new statement will return, this new keyword will give you the address to that object. When you do return, you are returning this value, this reference, back to the caller. So in the caller, you do account equals get account. This get account eventually will return a new bank account, which is created here. And when you return, you're returning address. Then after this call, the account variable in the caller will have the address pointing to the new object. Every object have a toString method. This toString method returns the class name and hash of memory address of the object. We can override the default method with our own to put more useful information, which we will cover later on. This toString method can be called explicitly. For example, you create a XYZ company object. You can print line toString. But because this toString method belongs to every object. So Java provides some way to simplify using the usage of this toString method. You can implicitly call it in print line or print when you directly put the variable. Print line and print knows that it should look for the dot toString method of that variable or of that address, that object. It's also called implicitly when you concatenate, when you use a plus sign. When you have a string plus something, it's actually calling the toString method of this XYZ company. Now, there's some more tricky questions regarding object passing. When you use the equal sign of operator for reference of variables, it's comparing the memory address. We discussed this before. It's not comparing the content of the object. But all objects have an equals method. The default operation equal method is to compare memory address, just like equals, double equals operator. But you can implement your equals method to compare the content of the object. Now here, if you use equals equals, this is a mistake because it's comparing the address, right? But you can create an equals method, which means comparing what's inside the symbol equals to symbol and share price equals to share price. That's the only thing that is equal, right? I think this is a typo here. There shouldn't be this. There should be a closing parenthesis here. So symbol itself is a string. Comparing with objects symbol, there should be a closing parenthesis here. Then comparing with the price. When the symbol equals and the share price equals, then that's truly equal. Then you return the status. So this is how you do object comparison by their contents rather by their memory address. And that's when you redefine the equals. This is called override. We will cover both override equals and the toString in further detail later on. But just that you know, since you already know how objects are passed as argument, that's how we look at equals. It's also possible that there's a null reference, which means it's not pointing to anywhere. It's pointing to nothing. There's no memory space. When you initialize, when you start to define an object or define an object variable, the variable is pointing to null until you use a new, use a new keyword to create an instance and assign it a value. If a reference is null, then no operation can be performed on it. But you can test if they point to null. For example, like if name not equal to null, then you can print the name uppercase. If name equals to null, is null, it's not pointing to anywhere, then do not do any operation on it.